In this section, we're going to cover segment postulates and segment congruence. Before we actually cover the postulates, let's cover some vocab. Again, if it's a vocab term that needs to be in your book, I'm going to underline it in purple. The first one is postulate. Okay, and a postulate is a fact or rule that cannot be proven. Okay? It is accepted, so another way to think about it is a postulate is a fact or a rule that is accepted without proof. So postulates are accepted without proof. You may see some books, and they call these axioms. Okay? We are going to call them postulates. The next thing I have is a theorem. And a theorem is a fact or rule that can be proven. Okay? And in this class, you are not allowed to use any theorem until we actually prove it in class or on one of the video lectures. Okay? We can't use something unless we know it's true. Okay? Postulates, we know they're truths because we just accept them without proof. Theorems, I cannot use until I prove them. Okay? So one of the a theorem that you should know about from middle school or regular algebra is the Pythagorean theorem. I am not going to let you use the Pythagorean theorem in class until we actually prove that the Pythagorean theorem is true using previously known facts. Okay? So a theorem is a fact or rule that can be proven, and let's just add something here, with previously known facts. Okay, and we're going to, in one of the next lectures, we're actually going to use the Pythagorean theorem. So we'll have proved it in class before you actually watch the next lecture so that you can actually use the Pythagorean theorem to do the work that we're going to do. Okay, between. Let's talk about between. What does it mean to be between? A point C is between points A and B only if point C, okay, I'm going to put points A, B, and C are collinear. Okay, and this is the point that's in the inside. Okay, I can rearrange these types of things. So if I have this, where I have A, C, B, right there, C is in between points A and B. They have to be on the same line. I'm going to do D, E, and F. Again, because F is not collinear with line DE, F is not in between points D and E. Okay, you do not need to put this in your vocab, but it needs to be in your notes. I just want you to understand that concept because we're going to use it. So we know what these things are. So the first thing we're going to do is we are going to talk about the ruler postulate, or postulate number 1. It's called the ruler postulate. You need to copy it word for word out of your textbook into your postulates and theorems notebook. But what I'm going to do is I'm going to give you something to put at the bottom of it that you should have included in your postulates and theorems notebook. So it's postulate 1. It is called the ruler postulate. And you can think about this is how do you measure things with a ruler? Well, one way to measure things with a ruler is to put the start of the ruler at one of your points and then to just read off whatever number's on the other point. But a lot of times rulers or measuring devices get broken and you can't start at the 0, okay? So basically what the ruler postulate says for us, and this needs to be added to whatever the book says, is the distance between 2 points on a number line is the absolute value of the difference of the coordinates of the endpoints. Okay? The distance between 2 points on a number line is the absolute value of the difference of the coordinates of the endpoints. It's the absolute value of the difference of the coordinates of my 2 endpoints. So I'm going to put, I'll just call this A and B. Okay, so how does this work? So this part has to be in your postulates and theorems. This is just an example. I want to know the distance between A and B. I have a ruler, hence the word ruler postulate. Okay. And on my ruler, that's where things line up. So I want to know the length or the distance, the ruler postulate. So it says take the absolute value of the difference of the coordinates of my endpoints. We'll call that about 2.5. We'll call that 7. That's going to give me the absolute value. So negative 7 plus 2.5 is going to be 4.5 in the negative direction. And I take the absolute value and I get 4.5. Or I could have put my 2 endpoints in the other direction. Absolute value of the difference of the coordinates of the 2 endpoints. So I got 7 minus 2.5, which would have just been the absolute value of 4.5, which is 4.5. Okay, ruler postulate works if you're measuring something or if it is between 2 points that are aligned horizontally or vertically in the coordinate plane. Because you can just pretend like they are on a number line, a straight number line. You cannot use the ruler postulate on a coordinate system if the 2 points form a diagonal line. You would either measure them with a ruler or use the distance formula, which we're going to talk about in the future. So that is the ruler postulate. One thing I want to talk about here are lengths of segments. If I want to talk about the length of segment AB, I'm either going to write it down as the length of segment AB with the segment bar, or I'm just going to put the AB without the segment bar on top. So if I'm talking about the length of a segment, I put the lowercase l to mean length of segment AB, or I just write it right here, which means the distance in between those 2 points. And that's going to be important. So that's postulate 1. Our next postulate that we're going to talk about is the segment addition postulate. Okay. And what it says is if I have a point that lies between 2 other points, that I can find, I can actually write an equation for their relative lengths. So postulate 2 is the segment addition postulate. Again, write it word for word out of the book on the page I told you to write it down on, and then add this extra information. So, key thing about the segment addition postulate. Okay, so I have AB here. C is in between A and B. So, if this is the case, I know that the length of AC plus the length of CB has to equal the length of AB. Or another way I could have written this is the length of AC plus the length of CB is equal to the length of AB. Okay, lengths are equal to each other. Okay, segments are not equal. I cannot say, I could not have just left the L's off and wrote the equal sign. We're going to talk about that when we talk about congruence in a minute. Okay, that's the picture I'd like you to put in your book, and here's the words I want you to add to what's in from the textbook. I want you to write little segment plus little segment equals big segment. So those are the words I want you to write down, and that's the way I want you to understand the segment addition postulate. Is if I have a segment that's broken up into multiple segments, I can use this math in order to determine their various lengths. So what we're going to do now is we're going to do an example, and this example needs to be in your notes. And this example uses this segment addition postulate. Okay? So I have 5 points, A, B, C, and D. Well, 5 points would make an E. They are all collinear. Here's some facts I know. I know that the length of AB is equal to the length of BC, which is equal to the length of CD. I also know that the length of AE is 26, and the length of AD is 15. Using this information, I want to find the following lengths: DE, AB, AC, BD, CE, and BE. Any time that I give you something that you're trying to find measurements or distances or something similar, my recommendation is you don't just go look to see what you're trying to find here one at a time. My recommendation is you fill in all your missing numbers and then go and answer the questions. It'll be easier in the long run for you. So I'm going to use my given information. I know that AE is 26 units long, so I'm going to write that down. And I know the distance between A and D is 15 units long. So let's look at this. If I know the whole thing is 26 and this part is 15, I know how long this part is. Because this segment and this segment have to add to 26. Or this red part is 26 minus 15, which is 11. The other thing I know is these 3 pieces all have the same length. And if I have 3 pieces that add up to 15, 3 things that add up to 15, each of those things is equal to 5. So I'm just going to mark in my distances now. I have 5, 5, 5, and 11. From this, I can now answer the question. How far is DE? It's 11. How far is AB? 5. AC, 5 plus 5 is 10. BD, 5 plus 5 is 10. CE, 5 plus 11 is 16. And BE, 5 plus 5 plus 11 is 10 plus 11, which is 21. So that is how you would use the segment addition postulate. Okay. Next thing we need to talk about is congruence. Okay, because we wanted to talk about segment congruence. And I'm going to develop what we mean by congruence here. We're going to talk about mathematical symbols here. So that symbol right there, the word for it is equals, and it means same size. This mathematical symbol, the little tilde symbol, mathematically means similar, and it means the same shape. This mathematical symbol, the equal sign with the tilde above it, we read as congruent. And it means that something is the same size and the same shape. Here's the big thing I want to warn you about. Lengths are equal to each other. Segments can be congruent to each other. So if two segments have the same length, we could call those segments congruent, okay? But as soon as I put the L in front of it or drop the segment symbol, I can no longer use the congruent symbol. So numbers are equal to each other. Shapes can be congruent to each other. So I'm talking about a number or a distance or a length, we're going to put an equal sign. If I'm talking about just the shape in general, we're going to put the congruent symbol. And you're going to see how this comes into play in the next lecture. I would recommend that this part gets in your notes. It doesn't have to be in your vocab, your postulates and theorems. It's just something that I want you to understand. And make sure that you copy all word for word the postulates and theorems from your textbook and add what I put in the video to your postulates and theorems notebook.